Well, hello and welcome to this IBM TM1 text analysis tutorial. This tutorial is part of a 7-day TM1 crash course. The tutorial shows how to create a simple user interface to extract and then retrieve and display the basic words contained in a sample text. The sample text used in this tutorial is Mark's Gospel in an English translation, just because this text is freely available in CSV format. The TM1 application consists of just two main processes. One to read the text and load it in a reference cube, and a second process to perform the word root extraction. This same process in the data section creates the analysis cube, which is the user interface to query the text for word roots. A couple of ancillary dimensions are used to filter out unwanted characters in the text, like punctuation marks, articles, adverbs, and the like. Using the analysis cube, the user can look for a word and display all the text lines where the word occurs, thanks to just a single but very powerful TM1 rule. Here's how the user's analysis cube looks like. This cube is called Gospel Analysis. The user looks for a word, like in this case again, and in the first and second columns we see the number of the chapters and sections where the word occurs in a line text. And you can read the line text just here. This is just a schema of how the application works. We have the Gospel of Mark cube here that contains all the lines in the Gospel of Mark, indexed by chapter and section. Then we have the Gospel Analysis cube, where the user can select a word, for instance anointed, and see where they are in chapter 6 and section 19, and 14 section 6. And through a cube rule, the line texts appear here, are displayed here, together with their coordinates. Okay, so we can start. The first tutorial task is to create and load Cube Gospel of Mark, the one that contains underlined texts. The comma-separated file is called Mark, and here is how it appears. We have a field text that contains the text line, then the coordinates chapter ID and section ID, so that the field text contains a line of text. Just notice that at the beginning of a new chapter we have the number of the chapter followed by a hash sign, hash character. Then the field CID contains the identification number of the chapter, while the field SID contains the identification number of the section. The two fields TID and sequential line can be ignored. Okay, let's look at the data source to load the Mark file with the process. First of all, we have to define the data source name and data source name on server. If you have downloaded the material for this tutorial, be careful and modify these values to the correct location in your installation. The type of the file is delimited by a semicolon, and the first record is used to store the title records. The variable section looks like this. We have a text variable that contains the text line. The CID and the SID will contain the values. These two fields will contain the coordinates of the chapter and section. TID and sequential line can be ignored. So we can talk about the prologue section then. The prologue section first destroys any previous instance of the Gospel of Mark cube. Then, to recreate the cube, let's first create its three dimensions: dimension chapter and dimension section that classify the text lines. We can initialize both with just the consolidated element all chapters and all sections. Then we need a measure dimension for the cube, which is gospel M for measure, so that we can accommodate the data values. We need a measure for the text strings. We'll call that line text. The type, of course, is string, and a numerical measure word count, which of course is type numerical. This is how the prologue looks like. First, let's recreate a new Gospel of Mark cube from scratch by destroying any existing Gospel of Mark cubes, if any. Then these are the instructions to create or recreate a chapter dimension, and we insert just the element, the consolidated element, all chapters, and in the section we insert as the only element so far all sections as consolidated element. The gospel measures are created here, and then we are ready to create a whole cube. It will be called Gospel of Mark, and it has 3 dimensions: chapter, section, and its measures. The metadata section is executed, as you know, is executed once for each record of the input data set, and for every line, for every record, we load the variables, the contents of the variables CID and SID in the 2 dimensions chapter and section, and we link them up to the consolidated element all chapters and all sections. Okay, now we can have a look at the data section, which is where the action is. First of all, we take the line text and we just put it as a string into the Gospel of Mark cube at the intersection of the 2 coordinates CID and SID. Then we begin the Steamroller algorithm that scans vtext for words. The string vtext remaining is set initially to vtext, the text line to be examined. The program loops until vtext remaining is nothing, and at every cycle vword is extracted from vtext remaining, starting from character 1 per length equal to the index of the first space in vword -1. This is how the scan function works. When the vword length is 0, as the algorithm always is looking forward for one word, we have the last vword in vtext remaining. Then we can set the exit loop condition vtext remaining equals null. If vword length is not 0, when we just roll over one word, setting vtext remaining as itself here, stripped left for the length of the extracted word. As we exit the loop, we proceed to update the word count measure of the gospel cube for the current line text. Okay, we have the opportunity to have a look at what we have just performed with the Gospel of Mark load text. We have loaded this cube here, you see. Here we have the chapter, here the section, and here we have the first line of chapter 1 and the word count, which counts the number of words in the text. For instance, here we have a 6, then the angels ministered to him. So that's 6 words in this line text. Okay, another thing I would like to show you, if we take the Gospel of Mark text load in the epilogue of this text, of this process, we create the default view. The cube name Gospel of Mark, view name default. If it exists, we destroy it. Then we create the view name default name and assign the subsets to the view name for chapter and section. We define a title dimension, a row dimension set, and this way we when the process is finished, we have a new cube, but a default view. You can also see that we create two subsets, chapter 0 and section 0, with the same script. The script just destroys the set if it doesn't exist, if it exists, and then by an MDX string, filter by level 0, on the dimension name, creates a subset that contains only the level 0, only the level 0 elements of the section. So then we are here, we see the dimension chapter with chapter 0 as a subset and subset section 0. Okay, the first task is done. Let's go to the second one, implementation of the create and load of the cube gospel analysis. Okay, let's do some analysis first. The gospel analysis, just remember, is where the user can select a word and be shown all the text lines where this word occurs. In the Gospel of Mark's cube, we call this dimension lexicon. Okay, let's see how we go about this. First of all, the Gospel Analysis Cube must be analyzed in terms of dimensions. Certainly the dimension lexicon must be a dimension so that the user can select the lexicon word. And in the worst case, a lexicon word may appear in all the lines of text of every chapter and every section of the Gospel of Mark. So the capacity of the Gospel Analysis Cube must be the same potentially as the whole of Gospel of Mark cube. Then we can understand that the dimensions chapter and section must also be part of the Gospel Analysis Cube. As for the measures, well, we certainly need text line, string, of course, because we want the text line to appear. Last, we need a way to link back a word with all the instances of chapters and sections where the word occurs. If we had a non-dimensional programming language, this would easily lead us to make a lookup table with the lexicon words as keys and a corresponding vector of pairs of chapter and section values as lookup data. But in TM1, once we recognize that this table will have the same volume as the combination of lexicon times chapter times section, we understand that the Gospel Analysis Cube is already equipped with the correct dimensional structure. We just need a flag, a 1 value, at the intersection of a lexicon element with a corresponding chapter and section element where the word occurs. Let's call this measure isIn, numerical, that expresses the fact that the word is within the line text at the chapter section coordinates. Now we are ready to create a Gospel Analysis Cube. The dimensions are lexicon, chapter and section, and then Gospel Analysis M, line text and isIn. To create load the cube, we need to read the Mark CSV file once more, and for every record of the dataset, extract the word from the text line, upload the words into the lexicon dimension, and then set 1 to measure isIn for the word chapter section coordinates of the line we are examining. The creation of the dimension from elements read in the data section of a process requires the use of the commit now form of the dimension element insert function, which is called dimension element insert direct. Before inserting a word into the dimension lexicon, we want to trim it from unwanted punctuation characters like commas, question marks, and so on, that may appear in the text after the extracted word without delimiting space. Second, we would like to filter out words in the text that we assume not meaningful for our purposes, like articles, the, prepositions on, for, and so on. To achieve this goal, we can think of a list of single characters that must be pruned from the end of the word, list trim character, and a second list of words that are not meaningful, list of not words. After trimming the word, we will look up in the list to know whether to exclude it from being inserted in the lexicon dimension or not. The best way to establish if an element is contained in a list in TM1 is to define a dimension with these elements, and then by the use of the function dimIx, dimListName, element to be found. If we return a 0 if the elements to be found is not in the dimension. So, before we proceed to the creation of the gospel analysis, create and load process, we just need to create a two-dimension trim character and not a word. Okay, we can just insert the elements manually in these two new dimensions, or by process, because we have provided in the tutorial database two text files, trim character text and not a word text. The files can be found in the source file directory. Now we are ready to comment on the creation and loading of the Mark CSV files for the second time, and this time we will put the text words into the gospel analysis cube. The difference is that we have to know if we are reading the first record in the data section for later use. So in the prologue section we just set a variable data section started to 0. Then in the metadata section, just as before, we create the structure dimension lexicon, and as before we just insert one element which is called all words, a consolidated element. Then the gospel analysis cube will also contain the two-dimension isIn, numerical, and line text string. Now in the data section part 1, if data section started is 0, then we negate this condition. Data section started now is 1, and we are ready to destroy and recreate the gospel analysis cube, because the lexicon dimension is already present, although it has just one element. The second part of the data section is again a steamroller scan of text. We implement the algorithm progressively scanning the vText, and just before we put the word into the lexicon dimension here, dimension element insert direct, because we are in the data section and we want the word to be inserted in the dimension and committed just now. Okay, then before we do that, we clean start and end of word from punctuation characters with the first trim character, and the second instruction if the word doesn't doesn't exist in the trim character ancillary dimension, then we put that word into the dimension lexicon. Okay, now that's all. We just have to create a rule, because before the rule we have this view of the cube analysis where we have already inserted as isIn in the 1 in isIn if the word Baptist is present, and we get that it is present in chapter 6 and section 20. So this is the rule. Line text S, this field here, if isIn is 1, then go to line text in the Gospel of Mark at the intersection of chapter and section. That's all. You need a feeder, of course. isIn is the feeder for line text, and that's all. Thank you very much. Bye bye.